New York City's like a graveyard. All the corpses like the way I play my guitar. You gotta be cute if you wanna get far. New York City's like a graveyard. All the tombstones, skyscraping. All the rock stars, double dating. So if you hate me, go on hating. You've been waiting your whole life for this moment to be waiting. In their fucking car, 12-stepping hippies hanging out at the bar. Suckers and fuckers and stupid retards. New York City's like a graveyard. City's like singing on the prairie. New York City's like a cemetery.
All right, so picking up where we left off last time, we were doing this car loan program where you borrow a certain amount of money, say $10,000, and you have to pay it back over a certain number of years, say 5 years. But they're, of course, going to be charging you 5% interest. Now, that's an annual rate. You're not paying that every single day or every single month or anything. Instead, each month, you only pay 5% divided by 12. And so that's your monthly rate. When you start out with $10,000, of course, you have a monthly payment, which is given by this formula up here. But the $188.71 that you pay each month, not all of that is going to the loan. Some of it is going to the interest, and the rest of it is going towards the loan. So that after you've paid the interest for that month, then you pay a certain amount towards your principal, and that updates the amount that you owe, only $9,852 and some change there. Consequently, the next month, that's how what your monthly interest rate is based on, or your monthly interest payment is based on. In other words, it goes down each and every single month until you actually pay it off. We developed this program by hard coding these test code these test values right here, and then of course we created months here. That's the number of years times 12, right? Then we came up with a monthly payment, and we made sure to round it to the nearest cent. We did that by using the Math Library's round function, but we realized that you can't round it because it would go to $189 rather than $188.71. But if you multiply it by 100, that shifts the decimal place over. Then you can use the round function as long as you shift the decimal place back after you're done. All right? So we were up to this point where we've got a monthly payment. Then we went month by month here, where we computed the monthly interest. We also rounded that. Your monthly interest was your monthly rate times your principal. And then the monthly principal that you're actually paying, right, this other figure over here, is the difference between them. So the monthly payment minus the monthly interest. Right? And then we need to update the balance to get the new balance and print it out, because what it looks like right now, let's remind ourselves what it looks like where we were last time on Friday. Let's see, GCC loan, right? There we go. And a bunch of warnings there. Also, you need to compile it with the -LM flag in order to get that math library stuff. There we go. So we've, we're getting the correct number of months here, 60 months. We've got that initial first month there. That looks correct. That doesn't look correct. Looks like we were screwed up, and that should be a period right there. Let's see if that's correct now that we fixed that. And run that. There we go. So $147.04. That matches our expected output over here. What we now have to do is we now have to update the balance. Right? Oops. Wow, that's really screwed up. Let me go ahead and reopen it. There we go. Now it's fine. All right, so we need to update the balance so that we're not stuck with this $10,000 balance that we're going to be paying for the rest of our lives. We never actually pay this loan down. All right, so we were using the principal here. What I want to do is I want to change this to a balance. Right? I don't want to base this off the principal, the original $10,000 every single time. Instead, I want this to be based on the current balance that we're actually paying towards. Right? I don't have to update anything here because the monthly principal is simply just the monthly rate, which monthly payment, and minus the monthly interest, which was computed in the line previous here. Right? Then I'll update the balance here. The balance is equal to the balance minus however much you paid towards it. That's going to be this monthly principal payment. So the monthly principal payment subtracted off the balance. Let's see if that gets us where we want to be. Right, so compile this again and run it. There we go. So we're getting different results now. In fact, in month 60 here, I've almost paid off my loan. I only have 14 cents left over. Right? But the problem here is that I am printing the wrong stuff. I'm off by one here. Right? I don't have that first month where it's $10,000. Then you pay this amount, and then you've got this amount at the end. So is there 1, 2, 3? That's because I'm not printing it, I guess. But even if I were to print it, it would be printing the balance, the same value here twice. So let's go ahead and actually I want to turn off on all warnings to see if I'm doing this correctly. And now you see the problem here, right? It's the same balance here and the same balance here. How can I solve this problem? Do what? Okay, I could move this down. GCC. Unfortunately, I'm going to be printing the same thing over and over again. It's just a different same thing. Let's go ahead and clear this, and then run it again, and then jump up to the top. There we go. 10,000, 10,000. Now I'm correct in the first month, but looks like at the last month here, I'm off by one still. Right? These are two different values in the same loop. If you've got two different values, what's one way that you can store two different values? In two different variables. So let's do that. What's the new balance? New balance would be the balance, or the old balance. I'm not going to call it old balance because that's what it is. Minus the monthly principal. Now, instead of I'll print the old balance here, and I'll print the new balance on the right-hand side. If you ever need to print two things, go ahead and give yourself another variable. You can't call it the same thing, but instead it's the new balance after that payment. Right? So GCC, let's go ahead and run this, and I'm almost there. Right? I am getting different values in each one of these. There we go. I'm getting a different value here and a different value here. But at the very end here, have I paid? Here's my new balance, right? Oh, actually, this is pretty acceptable. At the last month, I still owe $188.07. When I pay that down, to 78 cents of it goes to the interest, and $187.93 goes towards the principal. I am left with 14 cents here at the end. Now, this is typical with loans because that monthly interest rate or that monthly payment, that is based on that formula, which is rounded to the nearest cent. And because of that rounding, and each month there's rounding, you could be off by as much as 14 cents here at the end. Right? That's acceptable because usually what happens in a real loan is when you've got that little 14 cents left off, they just basically forget it. Or they make it so that your last payment is not the regular monthly payment. It's a little bit higher or a little bit lower. So you could change this now that we're done with that. I'll get rid of that. What I'll do is I'll change this to handle the last month separately because it is a potentially different value. How would we end up doing that? Instead of going up all the way up to an equal to the months, it would be. How could I change this so that it doesn't go all the way up to 60 months? Less than, strictly less than, right? Or less than or equal to months minus 1 so that it goes up to 59 instead, right? Lots of different options there. But then what you would have to do is you'd have to take this code and handle that last month separately. That's typical. Usually what you have to do is you handle the first iteration of a loop separately or the last iteration of a loop separately or something like that. But usually everything in between is the same. Otherwise, you wouldn't be writing a loop anyway. Okay? All right, we'll come back to this here in a second. But let's get some more practice. I'm going to go ahead and open up our demo code here and get rid of all of this stuff. And I just randomly searched, loop exercises in C for some suggestions here. This is kind of what's called coding kata. Right? I've never done any martial arts myself, but the term comes from martial arts where you repeat the same movement over and over and over again. Like wax on, wax off in the Karate Kid, and then it develops your muscle memory. And so this doing exercises like this can develop your code muscle memory, your mental memory here. And by doing this, you get more practice. You're going to be doing some coding kata in your lab tomorrow for loops. Let's go ahead and get some practice now, though. Let's write a program in C to display the first 10 natural numbers. Right? That should be easy enough. Int or a for loop or a while loop? Which one? I think that they were called for loop exercises. Yeah, for loop exercises. We can do either one, though. Right? So why do we want to go with a for loop? Why is it more natural to go with a for loop here? You know how many iterations you're going to go. You're going to go 1, 2, 3, 4, up to 10. So let's go ahead and start with I. Where should I start it? We're wanting to print 1 through 10 here. So let's start it at 1. I is less than equal to 10. All right. You could go strictly less than 11, but then that's weird, right? I want to go up to and include 10 there. I++. And here we'll just printf %d and then separate it by a space there to make it look nice. And let's go ahead and get rid of the rest of that. All right. And then after the loop, I want to make sure that I'm going down to the next line. So I'll go ahead and print a single end line character after that. So let's go ahead and go with demo. Oops, sorry. I forgot I there. There we go. And run that. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me change the exercise here. What if you wanted it so that there were commas there instead of just a space? Is that going to look nice? It looks nice for the most part, except for what at the end. That comma looks kind of bad, right? So what you could do is you could do a couple of things. Suggestions on how to get rid of that trailing comma. So an if statement, all right? So if I is less than 10, then we'll go ahead and do this one thing, right, where we are printing a comma. Otherwise, I'll go ahead and do this other thing where we don't print a comma. I'm just going to go ahead and take the same thing, but then get rid of that comma. Hey, it worked. What's an alternative? Much like the loan program where you have to change this to handle the last month separately, how could you change it so that you handle the last iteration separately? Strictly less than 10. Now I don't need this if statement, right? And then I will handle the last one outside. And %d and the line I. Now, before I try, is this going to compile? No, what's the error message going to be? I is not defined, right? Why? It's defined up here in your for loop. Consequently, it exists only within your for loop. And at line 16, it no longer exists. The solution there would be to put it outside the loop, right? Initialize it, check its condition, and now you can actually run this just like before. Great. Let's translate this into a while loop instead. Right. I'll have I up there still, but instead of just declaring it up there, I will initialize it right there as well for int I is equal to 1. Now I will put in I is less than, say, 10. Right? And I'm about to compile, works, and run it now. What was wrong? Yep, 1, right? What did I forget? I've got my initialization statement. I've got my continuation or termination condition. But what do I not have? My increment. And now, that'll print 1 to 10. If you wanted to, of course, you could put that into a variable. Int n is equal to 10, so that you only have to change it in one place. Right? Now, if you want to do this to 100 instead, right? Now it's in a variable and you didn't have to change your loop. Right? 1 to 100. I like that. Let's come back over here and look at another exercise. Print out the natural numbers 1 to 10, but then also find the sum. Okay. So let me go ahead and change this back to a for loop. For int I equals 0, I is less than n, I plus plus. Oops, sorry, we should start at 1 and go up and include n there. There we go, and get rid of that, get rid of that. Now I don't care about commas anymore, so I'll handle them all the same. Right? Now I'm back to the first version that we did here. As long as I got it correct. There we go. Right. 0 through 10. I do want to make it look nice though. So printf, go to the next line. And then printf, the sum is equal to %d. I need to get a hold of that sum there. Right. So what could we do? What do we need? How am I going to store the sum? I need another variable. All right. Is that good enough there? What value does sum have as of line 15 in this program right now? Maybe 0. But is there a guarantee on that? Nope, no default values. It could be 0, 9 times out of 100, or 9 times out of 10, it'll be 0. But it could be dead beef. It could be 32,000, whatever value was in that memory originally. Right? In fact, let's leave it like that for a second and find out if we actually get the correct result here. All right? Sum is equal to sum plus I. That's how I add I to the sum to get it. Is there a better way or more compact way of writing that? Plus equals I. Right? ECC. Oh, and then I need to print out the sum. There we go. In fact, I should have done it with a wall flag because it would have warned me about this. Oh, no, it's not. Oh, it should have warned me about an uninitialized variable right here, but fine. I'm probably going to be safe here on Ubuntu Linux. Yep, it's 55, just like over here, to see the solution. But sometimes, again, 1 time out of 100, it's not going to work, especially if you're on Windows with VS Code. It's not going to work there. Right? So I should initialize this to 0, otherwise I'm going to get weird values. Garbage plus 1 is garbage. Garbage plus 2 is garbage. I would end up with garbage throughout this. Does it work? Still? Yep. What about up to, say, 20? Does that work? Pull out your calculators and add up those 20 numbers. Is that the way to go about doing it? No. Avoid the grunt work. Let's see. Wolfram alpha. Right. Sum of integers 1 to 20. Right. 210. Did we get our correct answer over here? Yep. Okay. Write a program in C to display n terms of natural number and their sum. I think that's the same thing there. 1 to 7. Was there an average? I don't want to do keyboard stuff. Oh, there we go. Let's do the average as well. So how could I output the average with the program that I have right now? Sum divided by I? Careful, does I exist at line 21? Nope. Let's output. There we go. Oh, all right. I dunked that up, so let's go with a new terminal entirely. All right, there we go. All right, so GCC demo. All right. I does not exist on line 21 because it is only part of this loop, right? And I shouldn't be divided by I anyway. I should be dividing it by the number of elements that I am summing. Right? So let's go ahead and divide it by n over here. Is that going to work? Let's try it. What should it be? What was the answer again? Over here. Remember, I'm going to 20. So this should be 210 divided by 20. Let's ask Wolfram Alpha. What is 210 divided by 20? That's 10.5. Am I going to get 10.5 out of this? Nope. Well, let's change this to an F. Am I going to get 10.5 now? Nope. And the warnings are telling me about that. What is the issue right here? Yeah, a floating point number and truncation issue. I've got an integer divided by an integer. That's going to end up being an integer. So 10.5, you take that floating point part, 0.5, chop it off, throw it away, and you end up with 0 here. Or that's wrong. It should be 10.5, right? It should at least be 10. What's wrong with the sum? Did I get it wrong? What's wrong with n? It should be at least 10 point. Well, okay. Well, anyway, what's the fix here? I need to typecast at least one of them. There we go. Now we've got 10.5. Why was I getting 0 before? I'm not sure. Maybe I just hadn't recompiled, but that's weird. All right, so more coding kata exercises here. These are just write a program to display the multiplication table. You'll do that tomorrow in your lab. Write a program to display the multiplier table vertically. Here we go. N terms of odd natural numbers and their sum, and maybe even their average. So instead of going 1, 2, 3, 4, 5, 6, 7, all the 9, 10, all the way up to 100 or 20 or something like that, let's go by odd numbers. What would I need to do to modify this loop to do that? I still start at 1, still less than or equal to n, but instead of going up by 1, I would go up by 2s. How can I do that really shorthanded? Plus equals 2. There we go. That's 100, and then 100 divided by 20. Actually, that's not correct anymore, right? Because I need to know it's going up to 20, but I'm doing half as many, so that this would actually be 10 or something. But we don't need to fix that. Anything other interesting? Okay, here. Write a program in C to display a pattern like this. Right? So on the first line, line 1, it'll print 1 star. On the second line, it'll print 2 stars. On the third line, it'll print 3 stars. On the fourth line, it'll print 4 stars. How many loops do you envision here? Certainly one to go over row 1, row 2, row 3, row 4. But what else? Yeah, the columns. So row columns. What kind of a loop control structure do you think would be useful there? Okay, we could do a while. All right, let's do a for loop for the rows, though. All right, let's map this out. In fact, without any code whatsoever. For each row, 1, 2, say I don't know, 10. Right? We can put that in a variable. Dot dot dot. Print. Stars. Print row stars. Right? So row, if I wanted to do this as I is equal to this, print I stars. In the first row, you print 1 star. In the second row, you print 2 stars. In the third row, you print 3 stars. Right? How am I going to do that? How can I print I stars? Another loop. For j running from, say, 1 up to I, print 1 star. I know how to print 1 star. I just don't know how to print all the, like 5 stars or something like that. Right? But I can let this for loop, this inner for loop, do it for me. All right, let's translate this now. For int, say row, or do we want to go row or I? I? Okay, we'll just go with a regular I here. I is equal to 0. I is less than or equal to 10. We'll go for 10 instead of just 4. I plus plus. There's my outer for loop. Right? Now, how do I translate that inner for loop? For int j equals 1. J is less than or equal to I. J plus plus. Why did I have to use j? Because I was already taken, and j is next. Right? So let's go ahead and print 1 star. How do I do that? Percent. It's just a star. It's just an asterisk. Right? Let's go ahead and see if this gives us what we want. I never actually went down to the next line. The first one, you print 1 star, and then you go to the next line. The second one, you print 2 stars, and then you go to the next line. Go to the next line, go to the next line. Where would I go to the next line? Here. Would I do it here? Printf. Next line. That'll do it after every single star. So now instead of having all those, however many stars there are, now they're all now instead of horizontal, they're all vertical. Right? That's not what I want. Outside the inner for loop, but inside the outer for loop. Right? If I just did it down here, it would only ever do it once. Right? GCC this and run it. There. 1, 2, 3, dot, 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 all the way over here. Right? Nice, pretty stars. Okay. Any other? Same pattern here, but you're now instead of the star, you're printing out I. Same pattern here, but instead of printing out I, now you're printing out the outer for loop one. And a little bit more complex here. I don't want to get into that though. And this one, wow, getting that kind of triangle there is going to take a lot of computation, and I don't want to do that. Same thing with that. What I do want to do is go back over here to this loan program and make some improvements. So do you remember when we had to round to the nearest cent? We had to do it in 1, 2, 3 spots. Right? Not only that, but when I computed the monthly payment here, that was a really long line and complex. Right? What I want to do is I want to start building my own functions to do this. Right? Instead of relying on the round function, I would love it if the math library gave me a round to cents function. Then I wouldn't have to think about it, right? Unfortunately, it doesn't do that. So what I want to do is I want to add my own functions. This is a preview of what we're about to get into here. Right? I want a function called round to cents that takes as input some value, right? Amount or X or something like that, right? And rounds it by multiplying by 100, then rounding it, and then dividing it by 100 and giving you back the result. that's going to be a return value. Now, this looks almost exactly like what you would see if you looked at the square root function. The square root function looks something like this, double x. Right? It's called sqrt. That's the function's name. Our function's name is round to cents. It takes one single input, and it gives back an output. Right? Just like if you were to write f of x, right? In math, you were to write y is equal to f of x. Well, there's y, the return value, and then f of x, you are taking a value as input there. Right? One thing that you do with functions is that you document them. So returns the given amount rounded to the nearest cent. That is, rounded to the nearest hundredth. Right? This is good documentation. Right? It is doc style comments, so I've got a slash star star, a vertical line of stars, and then a slash, and it tells you exactly what this function does, right? Or what it's supposed to do. Now, do I have any definition of that function? Like, I just ended it here with a semicolon. This is called a prototype. Much like if you just declared a variable, int x, you have to declare that there is this variable called x, and its type is integer. That's what I'm doing here. I'm declaring that there is this function called round to cents. It takes one double input and returns one double value. Right? But I didn't actually say what it does or how it does it. Right? What I need to do is I need to go down here to the bottom of my program, and there is where I define it. Right? Instead of a semicolon here, I'm going to provide what's called a function body. You've been doing this for the last 4 weeks or 3 weeks or whatever we're on now. You've just been doing it with main and only main. You declare a function called main, you open a curly bracket, you have a closing curly bracket down here, and your function does all this code. Now I'm going to write another function to do different code that's not main. I'm going to take that amount, and I'm going to shift it over by 2 places. Then I'm going to round it. Then I'm going to divide it by 100 to correct for that shift. All right? What am I going to do with that value? I'm going to return it. So somebody comes into this function, gives you this amount. That amount is multiplied by 100, rounded, and then divided by 100, and it returns back that value back to you. Okay? Let's go ahead and change all of these now to round to cents, monthly rate, and now I don't have to do all that math over and over and over again. In fact, somebody else might like this function as well, and I can publish it as long as I move it out of this file here. We'll talk about that later, though. Right. Let's go ahead and get rid of this, round to cents. And here I don't have to multiply it. There we go. I only need to do that much. There. Much cleaner code, right? Because otherwise you might wonder, why are they multiplying by 100 and then dividing by 100, right? That doesn't make any sense. Oh, okay. I see. They're rounding to cents because they have a function that has a label, a name that says what it does. What about monthly payment? I want to compute the monthly payment. Let's go ahead and put that into another function and document it. Double monthly, or let's go ahead and get monthly payment. Generally, functions are verbs. So monthly payment is a noun. That would be a great name for a variable, but not such a great name for a function that does something. This rounds to the nearest cent. This gets you the monthly payment, or compute monthly payment. Right? Get monthly payment is just as good. Now, what are the inputs that I need for this this expression right here? To compute the monthly payment, you need the rate. Is that monthly or annual? I don't know. You need the principal. You need the monthly or annual rate. And then you need this n here, where n is the number of periods or months in the loan. So, how do you want to design this function? What inputs should we have here in order to compute the monthly payment? Well, certainly we need principal, first of all. Right? But we also need other inputs, not just one input. This is no longer like your math function y is equal to f of x. This is more like your math function y is equal to f of x comma y, or x, yeah, z, I guess. There we go. Hopefully you've seen functions like this. This is a three-dimensional function. Whereas this is a two-dimensional function, xy. This is now a three-dimensional function. You've got xy, and then it gives you z in the third dimension. You can also have in math, you can have x, y, and z. That gives you something else entirely. I don't know, foo. We're not good at naming once we get up that far. That's why mathematicians, when they get up this far, they start labeling them as x1, x2, x3. We don't do that because we know what our things represent. Principle. All right? What other inputs do you need for this formula right here? Rate. All right. Double rate. What kind of rate is that? Is that the monthly rate or the annual rate? Annual. Okay. Annual rate. Then why don't we call it that? Right? Now, what are we going to have to do with that annual rate? Divide by 12. What if we were to say, okay, well, no, I'm going to go with a monthly rate. Right? In other words, I'm forcing you to divide by 12 now. Are you always going to do you want to do more work, or do you want this function to do all the work for you? I want the function to do as much work as it can for me. Right? So I'm going to change this into an annual rate, which is actually the input to the entire program. I don't want to have to divide by 12 every single time. Okay? What's the third thing we need for this? N, which is the number of periods or months in the loan. So we could go with months. But what's a little bit better design? Just like I'm always, if I were to do an annual, a monthly rate here, or I'm going to divide by 12 for you here. What if you gave me years instead? Then I can go ahead and multiply that by 12 for you. I can do more work for you. I'm the function now, right? So let's go ahead and go with years. Why did I go with int here? We can't be fractional, right? So I'm actually taking three inputs to this function: principal, annual rate, and years. And each one of them has a potentially different type: double, double, and integer. But I'm only ever returning one thing. Okay? Document it. Computes the monthly payment of a loan with the given inputs. Right? See also whatever, see, I don't know, Wikipedia, monthly payment formula. Does it have something like that? Mortgage calculator, amortization calculator. All right, the formula. Yeah, that might be it. That looks like our guy right there. Right? So I'm going to go ahead and say see Wikipedia. href equals here. Ooh, what did I just do there? What is that thing? It's a hyperlink, right? Now, if you use hyperlinks, great. If you don't have to in this course, but if you know some HTML, you can start using it in your documentation, because as it suggests right here, you can go ahead and hold down. I'm holding down the command button. You can go ahead and open that up. Right? It takes you right there. And you do it in HTML because when this stuff gets, there are tools that you can use that will go and grab all of your documentation and render it as HTML or a PDF or something. And instead of seeing all this HTML here, all you'll ever see is here, and that it's a clickable link. Okay. All right. Let's go down and define it. All right. All I'm going to do is grab this up, this code right here. The monthly payment is going to be the monthly rate times the principal. Uh-oh, we don't have monthly rate, do we? We have annual rate. So let's go ahead and give ourselves a variable. Monthly rate equals the annual rate divided by 12. And we don't need 12.0 because one of them is already double. Now I've got the monthly rate and the principal. I don't have months though, do I? So let's go ahead and create months. And that's equal to how many months in a year? 12, and they ain't making more. There we go. Now I've got my monthly payment. I can return that value. Return this monthly payment. Okay. GCC. And run it. Oh, I was doing the loan. Anyway, get monthly payment here. There we go. I'm going to go ahead and replace this code here with principal. What were the other ones? Annual rate and years, I think. There. And that relieves me of the need of having to do, say, that month, that variable right there. Actually, I think I need them down here, but that's okay. I'll leave them. GCC loan. Years is undeclared where? Oh, I didn't call it years. What did I call it? Oh, I didn't have one. Okay. Int years. That's a 5-year loan. So that months ends up being years times 12. All right. That should work now. Bring in the math library. Good. Right. That's a preview. Let's start talking about this in a little bit more detail. Right. So let me open up a new note page. And again, these notes are available on GitHub. And actually, before we continue, just a reminder that I think it's today through Thursday is the career fair. I would highly recommend that you go over there at some point this week. In fact, I would recommend that you go every day just to check out the different employers because there are different themes each day. And there is one that's like STEM, technology and engineering or whatever. But you should definitely go to the other ones as well because every company needs software developers. I've gone several times throughout the years, and I've always gone to the engineering days, and they've got like a dozen construction management companies. But they're not looking for managers. They're not looking for construction engineers. Guess who they're looking for? You, right? Because there's not a single discipline or endeavor out there that doesn't need some sort of programming. So I would recommend that you go to every day. If you dress up, you can get free headshots, right? So that's a benefit there as well. Bring your resume, bring your cover letter, right? And just to hand them out to people. Even if you're not interested in working there, they're going to be calling you someday, right? If you're not looking for anything right now. Next week is the career fair specifically for the School of Computing. I think it's on the 24th. That's all. That's posted in bits and bytes. And then there's an ice cream social tomorrow, right? At 3:30 or something. I won't be here, but I think it's outside of Shore. Or check out the signage. There's stuff like that. And then as far as this course goes, a couple of announcements. Next week will be the Fix-It Week. Fix-It Week is one that you don't have a reading, you don't have a lab, you don't have a hack. You still have those sessions though. If you messed up on a lab or messed up on a hack, you can turn one in each. Right? One hack, one lab for reconsideration. So if you missed some points or you got 20 out of 25 and you want those 5 points back, fine, redo it. You're going to be handing it back in and then going to an LA and they'll evaluate it and give you your points back. One lab and one hack, though. That's in anticipation of your exam on Friday, the 27th, right? So not this week, but your exam next week is Friday. Because this week it's the home game day. There's no classes, and there's no help sessions either because UNL will be closed down. Yeah.
So you're not doing any online classes or anything?
I probably won't stream now. We're good enough on time that we're fine. So nothing on this Friday, but the next Friday will be your first exam. This is a preview of it. It's going to be very much like your hacks. You're going to be given a prompt. You have to write a full program. In fact, 2 different programs. You'll be handing them into CodePost. You can grade it. It'll tell you what your grade is. You can hand it. If you get something wrong, go back, fix it. Hand it in as many times as you want. It is an executable exam in that on Friday the 27th, it'll open up at 1 second after midnight in the morning. You have the next 24 hours minus 2 seconds to do it. It's designed for only 1 hour, but you have a 24-hour window in which to do it. No collaboration, so no co-authors. Don't talk to anybody. Don't use any code generation tools, ChatGPT or whatever. We do run this thing called MOS, Measure of Software Similarity, so it's pretty easy to detect, especially with these simple programs. If you're cheating on these simple programs, come on. I mean, come on. You're probably in the wrong discipline if you're cheating on your first computer science course. Not that you should cheat in your second or third CS course, but you're not in a good spot already if you're cheating, right? So we do run those. We do check for cheating, but you will have 24 hours. So we will not have lecture on that day. Instead, you can take the exam anywhere you want. Use your own computer, use the lab computers, whatever you need to do. You've got 24-hour window in which to do it. It's designed for 1 hour. If you need to take 3 hours, go ahead. If you want to work on one program, take a break, come back a few hours later, do the second program, that's fine, right? But that's what we'll be doing 2 Fridays from now. Right? All right, so I don't know. We can go ahead and call it. Too slow of a course so far? Too slow? Too fast? Too fast? Or okay, we're all Goldilocks. All right, there we go. Yeah, I like that. I offered that. All right, it's Goldilocks. It's not too hot, not too cold. It's just right. So we'll go ahead and talk about functions on Wednesday then.